In this lecture, we will learn what graphs are and how to implement them in Python. A graph is a collection of interconnected nodes. Some pairs are connected by links. Points are vertices, and links are edges. A graph is a pair of sets. We can represent a graph using an array of vertices and a 2D array of edges. Two nodes are adjacent if they are connected by an edge. A path is a sequence of edges between two vertices. The basic operations we can perform on a graph are add vertex, add edge, and display edge. Graphs have no concept of a root node, parents, or children. There are no rules for connections between nodes. All trees are graphs. A tree is a special case of graph. Graphs can be directed or undirected, weighted or unweighted, cyclic or acyclic, and sparse or dense. In a directed graph, the edges have a direction, an arrow at the end to show which way they point. In an undirected graph, edges don't show a direction. A weighted graph is when each edge also contains a numeric value signifying a weight. If edges don't have a value, the graph is said to be unweighted. A cyclic graph is when there is at least one cycle in the graph. An acyclic graph does not contain cycles. If a graph has significantly less than n squared edges, where n is the number of nodes, it is said to be sparse. For example, a graph with n nodes and n edges, or even 2n edges, is sparse. In a dense graph, almost every edge that could exist between the nodes of the graph exists. The number of edges is close to the maximum number of edges the graph could possibly have. A graph closer to the max number of edges is said to be dense. Similar to trees, there is no built-in graph data structure in C#. Graphs are typically represented as an adjacency list or a matrix. First, let's learn about implementing a graph as an adjacency list. A graph has a list of its nodes. Each node has a list of its neighbors. And with an undirected graph, there is duplicate edge information. Each node has precisely as many nodes in its adjacency list as it has neighbors. This is very space efficient, as you never store more data than needed. The downside of adjacency lists is that to determine if there is an edge from one node to another, it requires the node's adjacency list to be searched. It takes linear time for dense graphs. In the next lecture, we will learn about representing a graph using an adjacency matrix.